So I started doing that job in 1990. But to be honest, initially I was not planning to be a medical doctor at all. My dream was to be a veterinary, but I was so bad at school that indeed I could not attend the school of veterinary. Then I went to medical studies. And so I did my neurology, and I was fascinated by neurology. And initially I was planning to do tropical neurology, looking at infectious disease. And my mentor, Mr. Perret in Grenoble, told me, okay, we have an opportunity to develop an epilepsy surgery program in Grenoble, because someone, Professor Munari, could come to develop that program. I was not so enthusiastic because it was not my dream at all. And I fell in love with this discipline. And finally, I started my career by the end, because I started with epilepsy surgery and then went back to general epileptology. So that's the story of my career. So France is a very particular country in that SEG has been invented in France more than 60 years ago. So what the strength of France is that we have 17 epilepsy surgery centers doing SEG. One of the problems is that we do not have access to modern therapeutic options, which typically are the closed-loop stimulation systems or the DBS of anterior nucleus of the thalamus, or even the laser interstitial thermal therapy. So that's a problem in France, because we do not have the reimbursements for all these things. So we are very good in SEG, and probably we are not as good as we should be in terms of new therapeutic options. So probably the most important is to be able to place first the electrode at the right place, because all depends on that. So the main effort has to be put on how to analyze ictal clinical semiology, EEG, all the non-invasive things, to be able to make very good hypotheses on where seizures start, where they are propagating, and then based on that to put the electrode at the right place. So that's the first point. The second point is that SEG has evolved with time, and now we have tools that we need to develop that are able to quantify the signal. The best example, the last, I would say, 2 decades, is the identification by Jean Gottman and his group in Montreal of high-frequency oscillations. This is a new biomarker of epileptology, which has been developed in SEG in Montreal, and thanks to new methods of signal analysis. The third point is probably to be able to use SEG not only for delineating seizure-generating networks, but also to better understanding how the brain works. And I think that most of people that are doing SEG are doing also cognitive research. This is the case here. They're very famous in the field of micro-recording and memory processes and so on. And this is something that we have to do with depth electrode, because it opens a very important window on how the brain works, apart from how it dysfunctions as during seizures.